In Java, you may recall that every single method must be written within a class. We can have static methods in a class, and we can have instance methods in the class. In C++, we can have both of these scenarios, but we can also have global functions that are defined outside of any classes. So let's imagine this scenario where I have a source code file, myprogram.cpp, that has some class that may or may not have static or instance methods, but that also has global functions. In C++, any functional program must have a main function, very similar to how in Java, a given functional program must have a main method. In C++, the main function must be a global function, and it must have a return value of type int. The int return value tells you the exit status. It tells us, did my program run successfully or not? A value of 0 means, yes, my program ran successfully. Anything else, so any non-zero return value, means no, my program did not run successfully. So this main function should return 0 if your program ran successfully, or anything else if it did not. In C++, there are two ways to pass parameters into a function: pass by value and pass by reference. In pass by value, we just specify regular variables as the parameters, and this is essentially the same as how it was in Java. Basically, when we call a given function, we create copies of the arguments, and then the copies are what exist within the function called stack frame. So let's run this code snippet given a pass by value example. I would basically run these lines of code, which creates x with value 21 and y with value 42. These are both ints. And then I call this swap method passing in x and y. So I create a new stack frame. And within this new stack frame, I have a separate a and b variable. A copies the value of x, which was 21. B copies the value of y, which is 42. And then within this function, I create a new variable temp that stores a copy of a, 21. Then a gets set to whatever b currently has. B has 42, so this becomes 42. And then b gets whatever temp currently has, which is 21, so this becomes 21. Then, once our method returns, this stack frame gets released, but x and y remain unchanged. They're unchanged because all of the swapping that I did happened to copies of x and y, not x and y themselves. But in C++, in addition to pass by value, which is what we already recognize from Java, we also have pass by reference. So in this example, I'm passing in references. So my parameters are references, int ampersand a. It's a reference to some variable. So how will this look like when I call it? Again, I run that first little code snippet, which creates a stack frame that has x with value 21, y with value 42, and then I call swap x and y. This creates a stack frame. But actually, a and b are references to x and y. So a is actually a reference to x. It's another name for the exact same variable. B is a reference to y, so it's another name for the exact same variable. Then within this function, we create temp, which copies the value of a. A is another name for this variable, so it copies 21. Then a is set to whatever b currently has. B is another name for this variable, which has 42. So this variable that a is naming sets its value to 42. Then b equals temp, that copies the value from temp and stores it into whatever b is. B is this variable, and this makes it 21. Now this method returns, this stack frame pops off. Now we no longer have these references A and B, but the actual original variables have been updated. So X and Y themselves did indeed get swapped. So in pass by value, we create copies of whatever we pass in. Pass by reference, we create references to those exact same variables.